Why sky blue? This is a very interesting question with a very interesting answer. So, before knowing why sky is blue, we must know about what scattering of light is. Scattering of light. The literal meaning of scattering is something which is diffused, like bikrawa. What we call in Hindi is bikrawa. We say books are scattered. जैसे books बिखरी हुई हैं. So we can see an instant ray coming and striking this atom, molecule, particle, anything it can be, and getting diffused. And getting diffused means getting scattered in different directions. Like this is going here, 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 and this particle is scatterer. So a scatterer is a particle a scatterer is a particle or a molecule or a dust particle, anything it can be, which obstructs the path of light and scatters the light. Okay, so still what scattering is? Scattering of light is a phenomenon of change in direction of light after striking that very atom or molecule or particle, anything you call it. Particle, whatever it can be. The thing is, it should just obstruct it. Okay, so this is the definition of scattering of light. And if you want to know even more higher, then we can say that scattering of light involves bouncing back of the electromagnetic radiations and that same after striking that atom or molecule through which it is passing through. Molecule. So this is the we can say higher definition of the scattering of light. Scattering of light involves bouncing back of electromagnetic radiations after striking atom or molecule. So they've used the word electromagnetic because we can say the sun is an electromagnetic spectrum. That's why, and it is a radiation that it is striking back after striking a molecule. So this is what it is. Now the main thing is Rayleigh elastic scattering. Well, this is also a type of scattering only, but this scattering doesn't occur in all the cases. Something is coming, it is being scattered. We can't say that in all the cases Rayleigh elastic scattering is taking place. There are specific conditions for this. For example, or first we'll know what Rayleigh elastic scattering is. So I'll tell you only about it, how much it is required to know why sun is blue. If the size of the particle, this is the particle, if we say that particle is x, this is a particle which will be striking with this. So this is a scatterer, this particle I've been talking about over here. This is a particle. This particle x, let's say x. The size of this particle is much smaller than wavelength of that color. Okay, now we know that the sun is an electromagnetic spectrum. The rays coming from that can have so many rays: x-rays, uv rays, violet rays, radio waves, so many rays. But the rays which enter the atmosphere, after entering the atmosphere, get all the purification of the ozone that comes to the atmosphere, that is white light. And that white light also contains 7 colors. Okay, and all the colors have different wavelengths. So first case is that particle is much more smaller than the wavelength. Okay, so if I say that the wavelength of blue color is 4 into 10 raised to power minus 7 meter, and the wavelength of red color, which is the highest wavelength, is 8 into 10 raised to power minus 7 meters. So this is the wavelength, and the particles which will be acting as the scatterers for scattering of light, those particles, the particles which will be acting as scatterer, those particles are of size 10 raised to power minus 10 meters. This is much smaller than this. We can easily see like this is 10 raised to power minus 7 and this is 10 raised to power minus 10, and this is really small. Okay, in this case x is smaller than wavelength, so Rayleigh elastic scattering will take place. But in another case, if we say that x is bigger than the wavelength or the wavelength of the light, different colors of light, in that case all the colors will be scattered equally, like all the wavelengths are scattered nearly equally, so we will be able to see the combination of all the wavelengths, that is white color. So not a big issue in this case, not valid. So now let's come to the appearance of sky as a blue color. Sky as blue. Okay, so this is the ray of light coming with 7 colors. 1 2 3 4 5 6 7 7 colors. Each color has different wavelengths. This is different. This is, let's say, V I B G Y O R. Okay, so this is blue, this is red, orange, yellow, green, indigo, and this is violet. So now these all rays are entering into this, and here are small we can say particles or obstructors that are there. So we know, we know about the Rayleigh's, like I told you about this scattering. In this scattering, now what will happen? See, intensity of the scattered light is, or inversely, the intensity of scattered light is 1 by 4th lambda. Now what do we understand by this? The light which is scattered the most will have the least wavelength. Okay, so the light which is scattered the most will have least wavelength, that to the raised to power 4. If I say that blue color wavelength is 4 into 10 raised to power minus 7, and red color wavelength has wavelength of 8 into 10 raised to power minus 7, then automatically blue color is half. This means that it will be scattered more than around 16 times than that of red. It means that blue color is being scattered 16 times more than red, just because its wavelength is almost half. So half means 2 raised to power 4, so it is automatically 16. Like if you are good in mathematics, you can easily calculate it. I'm not that good in mathematics because I'm a biology student. So 16 times more than that of red. So here we see that the blue light is being scattered 16 times more. That is like much more. So we can't even think of sky being red. So we can the rays coming like this. So this is the rays 1 2 3 4 5 6 7. So red color will not be getting much scattered. O will not be scattered, yellow will not be much scattered, green will much not scattered, but blue color will be scattered the most, because it has like less wavelength, so it will go there, and all that with so many particles, obstructors. Okay, so this blue color will dominate. Like in bio we have studied about the dominating genes and all. So this blue color will dominate, and the sky will appear blue. Now you must be thinking that there are two other colors also, indigo and violet. Why the sky is not violet? Like the sky could have been violet also. Why isn't it violet? The answer is the violet color and the indigo color both the colors which are not much present in the light, which are not much present in light. Even in the sunlight, if we see it contains the energy level is very high for red and this blue and green colors, but it's not that high for the indigo color and violet and indigo color. So automatically, if it's not much, it will not be getting like scattered. And another thing is, so this is the point one, because it's not much there in the light and the energy level is also very low. Second thing is, we know that our eyes have rods and cone cells, and in which the cone cells are very sensitive to the colors. So cone cells to colors, right? Our cone cells also are much more sensitive for blue color than red or any other. So that's it. This is the simple phenomena. The rays are coming into this atmosphere, and after coming into atmosphere, they will be getting scattering. They will be scattered. Now it depends which ray will be scattering more, which ray will be scattering less. So the intensity of the scattered light varies inversely to the fourth power of the wavelength of the incident ray. As I've told you, the Rayleigh elastic scattering. So blue color has almost half the wavelength of the red color. So almost it will be scattering 16 times more. So 16 times more, it means that this will be dominating the sky and like dominating the all the colors, and this will be appearing in colors. But the thing is, violet color could also have dominated. I'm not saying that violet color is not scattering the most. It can be scattered, but the only problem is our eyes are not sensitive to violet color that much. They are very sensitive to blue color. They're in fact most sensitive to blue color. And the first thing is, they are not much present in the light. The energy level is not that very high. So maybe while coming in the atmosphere, we don't even see violet color. If over here in the light, the violet color would have been more than any other color, then automatically the sky would have violet. Just imagine sky being violet. It doesn't look like nice. So we should be happy when God has given. Thank you. If you like the video, then please like. I don't know, it's not that good, but it was my first attempt to make you explain about what scattering of light is. If you like it, just subscribe, or this will help me in making more videos. Thank you.